So it just says use the formulas below to convert between polar and Cartesian or rectangular equations. That's the only difference about what we're doing today. Before we were just looking at their coordinates. Now we're looking at their total equations. There won't be a lot of these on the assessment. This is kind of, some of these are the hardest that you'll do, but this is what is going to link for us some of what we did with circles to polar, because we are actually going to write circles in polar form. So it says sometimes the converted equation comes out simpler, sometimes it comes out more complicated than the original equation. So the benefit of being able to write equations in two different systems, polar and rectangular, allows you to choose the simpler version of the equation to graph. Also, we can't graph a heart using a rectangular equation, or we can't graph a spiral. So if you're trying to make animated designs, you might need more complicated non-functions. So polar can help you draw things with technology that you can't draw in rectangular form. So we already said we use Pythagorean theorem to solve for the r value. So r squared is equal to x squared plus y squared. That right there is the equation of a circle, right? X squared plus y squared equals r squared. That was our conic circle equation. So we're seeing kind of this relationship again in polar. I'm just going to write that another way. So you could also write it as r equals the square root of x squared plus y squared. So that's another, if you ever see r by itself, you could substitute this in directly for r. If you ever see r squared by itself, you could substitute in x squared plus y squared. So it depends on what the equation is telling you. And then we already said that the tangent is equal to y over x. So I could also write that as the tan inverse of y over x is equal to theta. So if I have theta by itself in the equation, I might want to substitute in this. If I have tangent in the equation, I might want to substitute in this. So having them written in multiple directions or versions allows you to substitute them in to whatever situation. And then we said x is equal to r cosine of theta, y is equal to r sine of theta. If you get confused which one goes with cosine or sine, it's just alphabetical order. X goes with cosine, C, and Y goes with sine, S. So they're in alphabetical order. You can also remember on the unit circle, cosine, comma, sine is your, coordinates. All right, so if I had R equals 3 written in polar, how would I write that in Cartesian coordinates? I could substitute in the square root of x squared plus y squared directly for r, but the way that we've been writing circles, what I would do first, I would square both sides of the equation so that I have r squared equals 9 as my first step. And that way I could substitute in x squared plus y squared equals 9. So this has a circle with radius of 3. And this is also a circle with radius of 3. One's in polar and one's in rectangular. Both have a center at the origin. So to me, this is like one of the most important conversions, being able to write a circle in polar and the same circle in rectangular, because we've done both of these now. I don't know, which one would you say is simpler? I guess r equals 3 to me is simpler, but when you start moving the circle around, like we're going to see in number 3 down below, I think this conic form becomes simpler because I can identify the center. So in some cases, polar might be simpler. In some cases, rectangular might be. Depends on what you prefer. So this one, to me, this is just kind of a garbly-gook of variables. I don't know what the graph of this would look like. I guess this would be kind of a rational function maybe, because if you divided by x, oh, maybe it's a quadratic. You'd have 2 minus 5x squared. So this is probably a quadratic. We're just going to convert it into polar coordinates. So anywhere you see an x by itself, you could substitute in r cosine theta. So I could write 2r cosine theta to get rid of 2x. To get rid of 5x cubed, I don't know, good luck. Minus 5r cosine theta cubed. You'd have to basically cube that r cosine theta. And then the other side, x times y, r cosine theta, r sine theta. I don't think it looks any better in either form. I think that would be a quadratic though originally. If I divided through by x, so if I did y equals 2x minus 5x cubed divided by x. Yeah, so this is really a quadratic with a hole in it at where x is 0. So I guess this would be simpler in rectangular form if I had divided it as a rational function. This is not any simpler to me, and I have no idea what this would look like. I can't even graph this on the calculator because you'd have to have r equals on one side. So definitely not simpler, just kind of practicing going between the two forms. So your only goal is to get rid of the x's and the y's and turn them into thetas and r's. All right, I'm going to show you how example 3 is also a circle and how it relates to kind of our conics unit. So if I want to convert this, what I'm going to do first is multiply by r on both sides of the equation. I currently have a cosine theta. The only way I can get rid of cosine theta is to have r cosine theta. So my first step, you wouldn't know to do this, I'm just teaching it to you, is you're going to multiply both sides of the equation by r. So that makes this r squared, and that makes this side, I can put it commutative property, whatever order I want. So I'm just choosing to put the r, negative 8r cosine theta. Now I can substitute something in for r squared, and I can substitute in something for r cosine theta to get rid of those. X squared plus y squared equals negative 8x. So technically your job is done. You have gotten rid of the r's and the thetas, and now you have this rectangular equation. So the last step says, can you convert your equation into something more recognizable? X squared plus y squared is going to be a circle or an ellipse. So let's practice completing the square like this is a conic equation by adding 8x to the other side, leaving some room to complete the square, and then you'd have 0 on the right. Right, all I did was add 8x. What do I add in here to complete the square? So you still need to know this for your final exam. It's not, well, yeah, this step might be on your test on Wednesday because it relates to polar and conics, but not all the ellipse stuff. What would I do to complete the square? Add half of this value squared is 16 to both sides of the equation. So this is a circle, x plus 4 squared plus y squared equals 16. So this is a circle with a center at negative 4, 0 and a radius of 4. So would you have known that from this polar equation? I wouldn't have. But I can read all of that information from conic standard form. So to me, conic standard form is easier for me because I can read this. I don't know how to read this polar equation yet, but in number 1, I was able to read this. It would just be r equals 3, radius of 3 from the origin. So it's kind of up to you of which is simpler. But I really like kind of that light bulb moment. Like at least it was a light bulb moment for me. When I was learning about polar equations, all of a sudden, wow, like there's my circle in completing the square as I transform from polar to rectangular. Like, wow, a circle can be represented in both forms and I can go between them. To me, that's like very like concrete example of how polar and rectangular relate. All right, here are some other common polar graphs besides the circle. I'd like you to be able to recognize when you just have a line. All of these are lines. So if they tell you that theta is equal to a certain angle, all that means is that the angle, so let's say if you had theta equals 30 degrees, all that is a line, why can't you see this good? A line through the origin at the angle of 30 degrees. If they said theta equals 100 degrees, All that is an angle through the origin going through 100 degrees for that terminal side. So here's 90, here's 100. So all of these are straight lines. If I wanted to convert this into rectangular form, what I would do is take the tangent of both sides of the equation. So I'm taking the tangent of both sides. The tangent of theta can be substituted with y divided by x. Tangent of my angle, that's just, I'm going to type into my calculator like the tangent of 30 degrees or the tangent of a half, the tangent of 45, whatever my angle is. So my final line, the slope of the line is the tangent of the angle. So y equals mx plus b, right through the origin. So you don't have to memorize like this if you can convert it. Just recognizing if you have theta equals something, it's a line through the origin. I can't graph this on the graphing calculator because I have to have r equals. So that's another kind of shortcoming of graphing in polar. It has to be able to say r equals, but this is a line. R cosine theta equals a constant. That is a vertical line. Whatever A is, it's a vertical line through that point. This is a horizontal line because it's y equals some value. So just good to know that, hey, this relates to a vertical or horizontal line. So circles and lines are important ones for you to know. So the last part, 7 here, they want you to take these 3 different common polar graphs and graph them on the same axis down below. So let's actually convert this one. I would take the tangent of both sides. Tangent of theta equals the tangent of 3 pi over 4. What is the tangent of 3 pi over 4? 3 pi over 4 is over here. So it's the tangent of 45 degrees, which is 1. So it actually is -1 as a slope. So this line would have a slope of -1. So it would be y over x. So y over x equals 1. Oh, sorry, -1. So y equals -1x is the first equation. So that's just a line through the origin with a slope of -1. And then the other one is just drawing a vertical line and drawing a horizontal line. I'm just going to do mine in a different color, but this is x equals 4. So that'd be a vertical line at 4. And the other one, I'll do it in maybe gray. This would be y equals -3. So horizontal line at -3. So to me, these are the biggies. Lines and circles. I'm probably not going to have you do one much like number 2. I just wanted to show you that it could look yucky in rectangular or polar form. So that last piece, converting r equals 2 secant of theta. I don't have any conversions related to secant. So what would be my first step in order to get this into rectangular form? What relationship does secant have to cosine? Remember, they're reciprocals of each other. Secant is 1 over the cosine. We haven't spent a lot of time on trig this year, so this is one I probably wouldn't ask you to be able to do on your own. But my first step, this is 2 times 1 over the cosine of theta. 1 over the cosine is secant. So what might I do next? I see an r and I see a cosine of theta. So I could actually multiply both sides by the cosine of theta to get it to the other side. Then I have r cosine of theta together, right? So this horrible thing up here is really just a vertical line at 2. Much easier to look at in rectangular form. All right, so now I'd like you on your own, and then after we do this, I think we'll go for our little walk. So the front page is converting from rectangular to polar, so these are coordinates on the front page. And then on the back page is kind of the newer stuff of what we did today, the equations. So work through those, and I'll kind of come around and see what you need help on.